Now, before we move on, it's important that you know that some elements never appear as just elements, as just by themselves. These are called diatomic elements. And the way that I remember them is Brinkelhoff. They are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. They are never by themselves. They always appear in a compound. So, you should never write just Br. It should always look like this. Br2. Or it should be Br with something else with it. Maybe an oxygen if it's bromate. Same with iodine. Iodine is never just I. It's either I2 or I with something after it. Only exception is if we are dealing with oxidation states, which we'll come to later when we get to electrochemistry. But for right now, please never write Br, I, N, Cl, H, O, or F without something following them, because they are never alone. Don't make bromine go without a bro. It can't handle it. Now, when you have a compound, it's important that you be able to determine how much of each element is contributing to the overall mass of that compound. We call this percent by mass, or percent composition. So if we're talking about ethanol, C2H5OH, and we're asked to find the percent composition of, say, carbon in ethanol, the way that we would set this up is first we need to find the overall mass, or the molar mass, the molecular formula, the molecular weight of ethanol, the entire compound. So we're going to do that the same way we did it before. I have 2 carbon atoms. I have 5 hydrogen atoms. I have 1 oxygen atom up, and I miscounted. I actually have 6 hydrogen atoms. And together, these all come together. When added together, they're going to all come together to make ethanol. C2H5OH. Make my subscripts good looking for you. Make it a little bigger. Alright. So now we just need to plug in what is the molar mass of carbon, hydrogen, and oxygen. Well, we look on the periodic table. I know that carbon is 12.01, hydrogen 1.00, sorry, 1.008, so we'll call it 1.001, and oxygen, apparently a star, is 16.00. And together they're going to equal what is the molar mass or molecular weight of ethanol, which we find to be 46.08. So that is the overall mass, the total mass of the compound. Now let's look at just the element we're interested in. We're looking at just carbon. So this is going to be the mass of carbon divided by the mass of carbon divided by the mass of ethanol times 100. Now if I did this, I would be wrong, and I would be very wrong, because I don't have just one carbon. There's not just one carbon contributing to this overall mass. There are 2. So I have to make sure I include that when I plug this in. I have 2 carbon atoms contributing to this overall mass. So it's going to be the mass of 2 times the mass of carbon divided by the molecular weight of ethanol times 100. So let's plug these in. From the periodic table, again, carbon is 12.01. Ethanol, this is what we calculated above. It's going to be 46.08. And since I'm the teacher, I should probably be thorough. We'll make sure I include these units. You do calculations, but I should probably model better behavior. And grams per mole. You plug that into the calculator, and you end up finding out that carbon contributes 52.13% of the mass of ethanol. Circle it, make it big for your grader, and you're good.